Dear audience, it's a pleasure for me to be able to chair today this session, which is about digital infrastructures and the European Open Science Cloud. We will have three panelists that I will present to you in a moment. I will be acting as the moderator, but before we go and present you our panelists, I would like first to give you a very short introduction about what this session is about. So this session will explore how the key components of data and research infrastructures have a transformative effect over our economy and our society. One of the key priorities that we have been working on in the Commission for this decade, which we call, by the way, the digital decade, is to be able to develop and enhance in the Union capabilities in digital infrastructure and knowledge. What are those capabilities? These are about building, supporting, enhancing, further expanding large data infrastructures that are capable of storing, managing, and sharing data, federating those at European level and interconnecting them with very high bandwidth networks, terabit networks, as we say, and making them, of course, accessible to everybody, and providing a number of services to our scientists and, generally speaking, to all the stakeholders, be that private or public stakeholders. And such services, for example, include computing services, could be also solutions that are based on artificial intelligence, however. We want to have these infrastructures first developed and second, rightly exploited and used by all the stakeholders. It would require a genuine collaboration among all our large communities of excellence across the European partnership, across the European scientists and researchers, and across the European partnerships that, for example, we launched yesterday, as we are very well aware now, including, for example, the EOSC partnership, the AI and robotics partnership, and soon to be launched or to be continued, the Euro-HPC joint undertaking, which is about high-performance computing, and so on and so forth. So, and would be the idea to be able to harness the capacity of Europe's digital and science infrastructures through the convergent use of fair data infrastructures, AI, HPC, cloud, edge computing, and whatever you would name it. So the collaboration is to start now, based on all those, and today's session is exactly about providing the possibility to talk about these infrastructures, to talk about the different components of these infrastructures, and highlighting not only the common issues, but the way we can make them valuable to all of you. Before I start the session and I present you our distinguished panelists, I would also like to give you some housekeeping rules. Would first like to invite you to write your questions for the panel discussions that will take place at the end of this session via the Slido tool. So you can connect via the Slido app by scanning the QR code via your browser with the event code, which is hashtag RIDaysEU. It's exactly what you see right now in the screen. In order to be able to identify who these questions come from, please name yourself with your name, with your last name, and your organization while using this interactive tool. So, and you can also mention, if you wish, who is the panelist to who you would like to address your question, but it's optional. So let me now introduce the first of our panelists, so who is Bob Jones. Bob is a senior member of the CERN scientific staff. He's a very recognized expert in distributed computing, and he's a director of the EOSC Association. So, Bob, it's a pleasure to have you there. Would you like first to provide us a short introduction? 4 or 5 minutes maximum, please. The floor is yours.
Yes, thank you very much, Thomas, and good afternoon to everybody. So, what is EOSC? So the goal of EOSC is to build a web of fair data and services for researchers across Europe. By fair, we mean findable, accessible, interoperable, and reusable data and services as a means of promoting open science. Thomas has mentioned yesterday the signature of the MOU for the European Partnership for EOSC, and that makes an important milestone for setting up this partnership as a way of federating the energy, the resources, and the capacity of the EOSC Association's members the European Commission and the member states to build this web of fair data and services. The recent establishment of the EOSC Association as a not-for-profit legal entity was an important milestone in getting to this point. It has a growing membership base of approximately 200 organisations across Europe, and the association provides a single voice for the advocacy of open science for all its stakeholders in a collective manner. It's recently published the Strategic Research and Innovation Agenda, which outlines this vision, the objectives and the challenges, as well as a roadmap for the further development of EOSC over the next 10 years. A key step in this development is a change in culture, so that open science becomes the new norm for the stakeholders involved, starting primarily with the researchers themselves and supported by their employers and funding agencies in terms of incentives to adopt open science. Training, of course, will be important to achieve this goal by increasing the level of awareness of open science and to integrate it into the daily research practices. A short-term goal with a concrete objective for EOSC is deploying the minimum viable EOSC. If you want the first viable, useful version of EOSC for the research community. And this will enable publicly funded research to share and reuse data and services across scientific disciplines and national boundaries. It represents a demonstration of the value of EOSC and provides a vehicle for engaging with the researchers and gathering their feedback. The implementation will be driven by a number of projects, both funded by the European Commission and nationally, and they are actively contributing towards establishing EOSC. The EOSC itself, it'll include something we call to EOSC Core, which is basically the housekeeping services that support interoperability in the federation. Then there's the data sets themselves, the high-value data sets coming from the different research communities around Europe. And then EOSC Exchange, which is a form of marketplace for services and data, and all this building on the GEON network in order to create an incarnation of data spaces that provides an environment conducive to multidisciplinary activity. EOSC is seen as a cross-cutting data space for research and innovation, enabling the sharing of data, which is fundamental to EOSC's objectives. It's not the only data space, but it's a cross-cutting one. There are others planned in different sectors. And since EOSC is seen as a horizontal data space with federated research data that has value in a number of different economic sectors, be them public or private. And so this will create opportunities for new insights and knowledge, promote data-driven decision-making, and the development of new services based on the reuse of research outputs. Of course, EOSC depends heavily on the ability to store, transfer, and process data using a variety of facilities, including HPC, cloud, and edge computing, which need to interoperate so that Europe's researchers have seamless access to these services. So, of course, EOSC is looking as a co-program partnership to collaborate with other European partnerships, including the Partnership for High Performance Computing and for Artificial Intelligence, Data, and Robotics to make this possible. And I'll leave it there. Thank you.
Thank you, Bob, for this introduction to EOSC and to some of the challenges of EOSC and its links and possibly coordination activities with the other relevant partnerships. I would now move to Professor Dirk Pleiter. So Dirk is a very well-known also personality, I would say, in the world of high-performance computing, EOSC, just to name a few. So Professor Pleiter is a professor for computer science at the KTH in Sweden. He's the director of the PDC Center for High-Performance Computing at the KTH, and he is also a senior researcher at the Jülich Supercomputing Center in Germany. And he is one of the main drivers, if I understand well, Dirk, of the eBrains infrastructure that is the infrastructure for the neurosciences that we are creating under the Human Brain Project or as a byproduct of the Human Brain Project. But these are not the only, I would say, activities that you have. You are very closely linked also to what we do in the EOSC, to what we do in the Destination Earth, and many other things. So the floor is yours.
Yes, thank you very much, Thomas. It's an honor to be here. So when we think about, say, digital infrastructures in the future, I think it's important to reflect a bit on what I consider, say, basic developments which we are seeing. And they are to some extent also, say, linked to what Bob called, say, changeover of culture. Now, first of all, we observe that there is an increased need for, say, compute-intensive workloads. And that's not only, say, for the more classical simulation scientists, but I mean, now with artificial intelligence and machine learning methods becoming, say, standard methods for research, that means that we have an increasing number of communities which have in common that they need HPC resources. And that's why it's good to see, say, the investments of EuroHPC. Now, at the same time, we see that an increasing number of science and engineering communities have, say, increasingly complex workflows, and that we are talking about workflows which also, say, extend, for instance, beyond HPC centers, and require then actually also different types of resources. I mean, just to take, say, some examples are, for instance, from the area of the physics experiments, where we have, say, the production of the data obviously outside of the data centers. But at the same time, we observe that some of these communities are having increasing need also for HPC resources. I mean, in the area of particle physics, in the area of light source and neutron source experiments, or the radio astronomy. So what I would conclude from that is we do have, say, a clear need for being able to combine, say, different types of compute and storage resources. And then finally, as was already mentioned, I mean, we see that these communities are, say, organizing themselves at the European level. They are distributed. Some of them are generating data in a distributed manner. So that's where also, say, the need from the user side for federation is coming to. Now, what does it mean for HPC centers? It means that they have to undergo a transformation from being, say, an operator of a large-scale facility, a supercomputer, to a service provider where you provide a set of services which are deployed on a variety of different resources. And so it's about, say, establishing, say, a infrastructure services layer where that can still, say, include high-performance computing, or with more generally talking about, say, scalable computing services with some attached fast parallel file systems. But it also requires, for instance, virtual machine services or container orchestration services or storage services, which are much more suitable for sharing data, in particular when it also processing comes to sharing then or working then with more sensitive data. Now, I think it's important to realize that this is not only about, say, changing the way of how we architect digital infrastructures in the future. It is exactly also about this change of cultures, in culture in particular when it comes also to our relations with science and engineering communities. And this is where I see a very important step which are to be made if we as HPC centers are defining us as e-infrastructure service providers, which provide some more generic services which can be used in by multiple science and engineering communities, because we have to be able to do some consolidation, otherwise this is not going to scale. And at the same time, we delegate, say, part of then also the responsibility for services, but in this case, domain-specific services, then to research communities. And that's where, for instance, also the results of the Human Brain Project is a perfect example for that. We have, on the one hand, we have say, as a result of the Human Brain Project, eBrains as a research infrastructure, which is very domain-specific and takes the responsibility for domain-specific services. And as a second outcome, we have the Phoenix infrastructure, which is based on a collaboration of, by now, 6 leading European supercomputing centers, which take the responsibility for providing the e-infrastructure services, for instance, to eBrains, but obviously also with the ambition to do it also to provision these services also for other communities. And that's why we started in a very active dialogue, for instance, with stakeholders in the context of Destination Earth, or for instance, also the different S3s which are organized in EOSC. Just one very final point which I would like to make, because it's also, say, part of this culture, is that we have to be very much aware that it's very important that we do this in a co-design approach. So we have to have this very close interaction with the users of this infrastructure so that we make sure that we serve the need of these research and communities. Thank you very much.
Thank you, Dirk. And then we will now move to our third panelist, who is Madame Franois Soulier, a specialist in data mining and big data. She's a member of the board of directors of Hub France Intelligence Artificielle, one of the key contributors when we have built the European strategy on artificial intelligence. Françoise, the floor is yours.
Thank you very much, and thank you for the invitation to talk here with you. Basically, I will come back to exactly what you were mentioning, the work we were doing at the AI high-level expert group about 2 years ago. We made recommendations for leveraging Europe's enabler for trustworthy AI. And the first enabler that we identified was data and infrastructure for AI, which is exactly the topic of the session, right? So I'm going to just repeat the topics that we identified at the time, because they're still valid, and actually we are working on them. If you look at the contribution of the Commission in the different documents, the data governance, the European data strategy, the different programs which are in place, basically all these different programs have heavily used the information that we had provided. We were actually there for that, right? So the first thing is, the first enabler that we identify was to support AI infrastructure across member states. So this meant different things. One thing was distributed clusters, cloud, also edge computing, large RAM, fast networks. This was considered very critical for us at the time, and of course still is. The second topic, which is being developed by the Commission at the present time, is what is called now the testing facilities and the sandboxes, regulatory sandboxes, where companies need a space where they can basically go and test their ideas or on their data sets. The second one was to develop legally compliant and ethical data management and sharing initiative. And the words here, important, of course, legally is important too, and ethical as well. But the important word is the sharing problem. We need a data platform for AI, which will include all the necessary tools for data governance, collecting, etc., annotation the data, storing the data, networks, fast, of course, analytics software, because when we have the data there, we need to do something with it, and this is where AI comes in, and most importantly, of course, data sets. So data platforms are critical. The second one is probably to have a data repository EU-wide, where we would have a common annotation and possibly standardization. When we talk about data, the fact that data are not standardized is really a big issue. Indeed, we were advocating the creation of trusted data spaces for specific sectors that is probably vertical data spaces suited for the different domains in our economies. Indeed, we want mechanism for the protection of personal data and individual. This is very critical to the vision that Europe has of what trustworthy AI should be. And finally, maybe an idea of having European data sharing infrastructure becoming public utility infrastructure, just like road, train, or this sort of thing. Because data is becoming so important that maybe they have to be protected more carefully. This might require a data donor scheme. I might come back on that. The third topic we had was about the support in the development of an AI infrastructure. So that include open source AI software libraries. Today, everybody in data science is using libraries, very often open sourced by big players, and these big players are all Americans, and soon they're going to be Chinese. And we think, and we thought, and I still think that we need to develop our own libraries in Europe. we also probably need to support the development of hardware and compute infrastructure which are dedicated to the new field of IoT, because AI and IoT need specific kind of tools, basically edge computing, where the compute is close to the data, basically. Maybe finally, a last topic which is often overlooked, or was often overlooked, and now we had various calls which reminded us of a problem, which is the trouble with cybersecurity. So we need to have cybersecurity infrastructure which are basically enabled by AI. AI is a very powerful tool to help cybersecurity issues. AI is also a very good tool to hurt cybersecurity, because AI provides very good tools against security. So we need to have tools for that. So infrastructure for cybersecurity to protect our networks, our data, our users, our society, basically at large from risk. These are the important topic I think we had identified at the time. And if you look at the different documents that the Commission has issued, in the last couple of years, all these issues are spread all over. So these are the issues we identified at the time, and now the Commission has taken measures to implement these things. So progressively, this is going to be developed. The last one being the AI Act, or the regulation of AI, which builds on top of that, indeed. Yes.
Thank you very much, Francois. So, Bob, back to you. So you heard quite a lot, we heard quite a lot, not about the challenges of EOSC, in particular, the first 2 3 years, as you said, but beyond. The challenge very clear mentioned about also data and the role of data, the standardization of data, the fair data, as you mentioned, etc. So, but you hear also all the other infrastructures that we're trying to develop next to the EOSC. So all these data spaces, all these high-performance computing facilities, the AI story that Francois so well explained also to us. So how do you see, therefore, all this coming next to EOSC or close to EOSC, to the benefit of EOSC? Where do you see the benefits would come from? And do you see it also from the point of view of, are we going to manage the fact that we will bring researchers in EOSC, or are we going to continue with the old model, which is the model of individualist researchers? Sorry for being so blunt sometimes, but the notion of open data, open science infrastructures, open research infrastructures is a totally new notion that is evolving out there. So how EOSC is going to build and profit from what we are all, I would say, having as a challenge to build for the next few years? What is your standpoint?
Yeah, that's a very good question, Thomas. And I think you have to remember that we're not starting from a blank sheet of paper. There is already a lot of open science initiatives existing, and which can contribute to this model, and which can help us bring in the HPC and the AI partnerships. First of all, already Dirk mentioned the research infrastructures, S3s. Around those, there are significant science clusters who today are actively engaged in open science practices. They represent important leaders in the ability to bring these models to a wider research community and to the society in general. They have important data sets, which they are willing to federate via EOSC. They have important related services and processes that they've developed over time in order to service around this data. All those will be contributed to EOSC. They're there today, and they're actively working to bring those together. So we're not starting from a blank piece of paper. There is active involvement, and that's going ahead. Coming to the engagement with the other partnerships, let's start with HPC. It's quite clear, as Dirk pointed out, this transition that's going on in the HPC centres to move away from strict HPC capabilities are directly in line with what EOSC requires as well. We would like to be able to see that those services that are coming from these transformed HPC centres are accessible via structures such as the EOSC exchange, And there are already these competence centers and centers of excellence that are helping researchers understand how to make use of such advanced HPC-related services. Francois mentioned for AI the idea, the importance of cybersecurity. That's a fundamental element in the architecture of EOSC as well. We should not believe, just because we're doing open science, that everything is freely open all the while. Fair means that you can be as open as necessary, as open as possible, and as closed as necessary. There are valid reasons why researchers may need to control the access to their data and services, and that is fully foreseen in the EOSC model. The value of AI, of course, is we want to use these techniques in order to analyze these increasing data sets and the combination of them as well. Already here at CERN, we are actively now making use of machine learning techniques to improve the high-level triggers, which will help us deal with the ever-increasing amounts of data that are coming from the Large Hadron Collider and need to be processed in order to extract this new knowledge about our universe.
Thank you, Bob. So if I go back to a little bit to Dirk, you mentioned, we heard Bob saying that HPC would become a fundamental service and needs to become a fundamental service through secure access for all our research communities. At the same time, we heard you saying HPC as a service, interactive computing, throughput computing is another term. Is the future of HPC and HPC as a service to be provided through a cloud-based platforms? But then what would that entail for, I would say, the HPC as a relatively closed club of supercomputers we have today, which is accessible for very large workflows that require hundreds, sometimes even hundreds of millions of working hours. How do you see that? Are we going to open these kind of very high-end machines and very expensive machines, by the way, to the whole scientific community? Is the future model of HPC as a service this one, something different? How do we cope with the trade-offs that we just heard?
Very good, but actually also a very complex question, because it requires answers at quite different levels. Now, of course, an HPC system will, to some extent, because we are talking here about an export control technology, will need to be protected. But I think we can rethink also what we do. What do we mean with protection? As of today, with researchers having directly access to HPC, it means we have to have a very strict control on the identity of this researcher to make sure that nobody gets access directly to the HPC resources in a way which we don't want to happen, or which we are not allowed to make it happen. There are other ways of how you can control it. If you, for instance, think about having, say, services which allows you then to trigger a very controlled workflow, then you don't need to have the strict control on this user. So this is one way of how we can actually open up HPC services without, say, compromising in the security, and at the same time also improving, say, the usability. Now, that sounds, of course, simple. There's a lot of, say, policy questions related to that. It's also, say, the question of what are, say, the right workloads which should be, say, available. Because if we look in our daily practice, there's a very large diversity of, say, workloads running in our systems, because it's used by scientists. And they all do it a little bit different, which is important, because the little difference can make, say, the important difference. And that's why, again, this engagement with communities is so important, so that we find, say, a good way of how can we make, say, the use of the HPC resources easier. And just to make it as also the last point, which is, say, important in this context, because you also made reference to these very expensive resources, how do we find good models that we can ensure that when these resources are used for free, and that is, say, today the typical model, at least for the academic researchers, how do we make sure that best possible use of these resources are being made? Now, I don't know the answer as of now. We have to explore it. Maybe we have to go to a pay-as-you-go model, so that the researcher will have to use its budget and then think twice what kind of calculation he or she starts. Or we find other ways of how to ensure, say, an excellence-driven access model.
I must confess that the pay per use is not a model we introduced in the revised regulation that we have just, put ahead with the Council for the next 7, if it's not for the next 10, 12 years on the Euro-HPC joint undertaking. This is more a model that we used for SMEs, but it's an interesting principle, and I'm pretty sure with the scientific community will have to come on this. And actually, the thinking of how we can link it best with the EOSC infrastructures that we are developing is also certainly, I would say, the changing model that we'll have to consider. Because we think about the high end of the science, but what about the long tail of science, which we need also to serve in one way or another with computing services, not only high performance computing, but also computing services. And now I come a little bit to Franois about this role of AI. It's clear from what you said, Franois, that AI in Europe to be developed, we need data. And today, all the algorithms and most of the big companies that you mentioned, and sometimes academia, come from US and soon from China. So is it a chance for us that when we develop these kinds of large data infrastructures, like the EOSC ones and the other ones that we announced in our data strategy, could provide us a chance for developing the AI I would say, large effect that we all expect to happen? Do you expect that really to be the case? You mentioned about a platform for AI. Actually, I would even dare to say AI is a service for the wider community, since we could be exactly in line with the HPC as a service, so AI as a service, etc. So how do you see that evolving? Can we do it, and under which conditions? Are we going, for example, to provide incentives for the researchers, again, or for the big industry or for the smaller industry to provide this data to these data? How do you see that evolving and happening?
Yeah, that's a very complex question, and actually it's at the very core of what AI can do today. It's true that today AI is mostly machine learning, and machine learning means AI means data all over the place. So I'm going to talk more about the private sector, because my association is France AI is basically working with companies and trying to accelerate them to develop and to develop their activities in AI. So the private sector, they need data, and it's obvious that most of the time they don't have enough data. And one solution for that is actually to share data. So I'm going to focus on this issue because it's a topic which has emerged recently and which is now basically getting some success. So let's see a very concrete example of something we did at the Hub, and you'll see whether we can take something out of that. So suppose you're a company and you want to work on speech recognition. You want to make a product, for example, to translate speech to text for a chatbot. So your user talks in like I'm doing, and then you get the text, and then you can move that to other applications who would prefer that. Good. If you want to do that in English, that's pretty easy. We know the algorithms, deep learning, convolutional network. They do that perfectly fine. You just need enormous data set. And when I say enormous, if you can make it 1 billion occurrence of speech, this is the kind of data I'm talking about. So in English, zero problem. You find lots of very rich annotated data sets that you can use. Now, if you want to do that in French or in German or in any of our European languages where we have maybe at most 60 million people speaking the language, then the issue is completely different. You do not have large annotated data sets, right? So at France AI, what we did, we helped a group of about 20 startups in the field of speech recognition. Of course, all competitors, right? And the idea was they would assemble with research labs and they would prepare a proposal for a project to build a data platform where each of the partners would bring their own data sets and each would benefit from the whole collection. And this is called Le Voice Lab. And there are the major companies in speech recognition in France. Okay, so that sounds pretty nice. That's obvious. This is what you should do. If you want to do speech recognition in France, you need to do that. So benefits are clear. Now, what are the difficulties? Because there are a few you must solve. And basically, I will talk about two major difficulties. The first one is the infrastructure issue. We say, okay, data space, very good. I'm going to share the data. Very nice. Where do I put them? Where do I put my data or the different data? So this is the first question you have to solve, which is the infrastructure where you're going to put the data. Now, putting the data means it has to be very easy to deposit the data and then to access them and use them. So you need lots of tools for these different, stages in the AI process: data wrangling, data collection, data, etc. Of course, when you put data in, you want to make sure that these different formats are standardized. Okay, probably you would have vertical data spaces because a standard would not work across every possible domain. It has to work across, vertical domains. Okay, but you have to do that, and it's not a problem which is solved. And now you would want probably to control the access. You would want maybe to limit the access to certain quota during a certain time, to certain people for certain time periods. So all these tools, when you say sharing data, all these tools actually have to be there, otherwise you don't share, right? So this is the infrastructure issue of a data space or a data platform. Now, there is a second issue, which is probably the most important, right? We say ladies first, but here is the last one, which is the most important. The important issue here is a business model. If you do not have a business model, sharing is not possible, because the most important thing for a company to do anything, the only reason, maybe not only the only reason, is basically to benefit from it. So if the company will not benefit from it, they will not share data with their own competitors. So you have to find a solution for that. So you have to build business models which make sure that all the parties will get their just share of the benefit from the data they put and the data they extract. So this might require some new thinking, because we're not used to have a mechanism like that, where you build a consortium of competitors, basically, and you make sure that everybody benefits from it. So this is very critical. You might also think of a marketplace model, where not only the providers of the data, of the people who are sharing, benefit from it, but they might also benefit from the selling or reselling or whatever of the data to other external companies. So these two issues, infrastructure and business model, are really very important. Now, how can we make it easier for the private sector to do that? Many ways. First way probably is the power of example. If I can show success stories with precise solution of infrastructure which were put in place, precise new business model. I'm working with GPI, a global partnership on AI, and one of the work we did was actually on new business models for AI, and this is the kind of thing we need. This will help to decide basically companies to share. Now, another issue is the possibility to share securely.
Franois,
yeah?
may I interrupt you?
Yeah.
Would like to spend 5 minutes. All is super interesting, but I still like to have a little bit of interactivity with the audience and take maybe one or two questions from the audience. Sorry to interrupt you. So I hope you understand that it would be good at least to take one or two questions from there. Is that okay? Thank you. So I'm turning a little bit to the colleagues from Slido. So are there any questions that would that were submitted so far from in Slido, please, that we can take? So we have a question from This is for you, absolutely.
Okay. So what time scale do you expect that the EOSC will provide data and services also to the private sector? So it's a very good question. It's part of the roadmap that's been outlined already in the Strategic Research and Innovation Agenda. We have 3 phases defined. The first phase, which lasts sort of 2 years, is establishing the MVE and with use cases primarily for publicly funded researchers. They're the first user base we're looking at. Beyond that first phase, so we're talking from 23 onwards, we're expanding the use of EOSC for the wider public sector. So this includes government, education and so on, but then also, of course, the private sector. And we are already discussing with some of our colleagues who are actively involved in the Gaia X initiative to see if we can jointly work together in helping establish these data spaces across different business sectors where they could potentially benefit from the data services and data sets coming from the research sector as well.
Very good. Thank you, Bob. Shall we take a second question? There is still a little bit of time. Well, I would not expect that we'll take a question for me. So how will existing research infrastructure, specifically known as free initiatives, be supported to integrate the data, digital tools and data into EOSC? Maybe, Bob, this is also for you, but to some extent it is also for, I would say, for Dirk to consider a little bit.
Okay, well, I'm not speaking on behalf of the EC, right? Okay. But,
of course, this is not what I'm asking to do, for sure.
Okay. But, so I cited the example earlier of the S3 research initiatives and the clusters that are going on as early one. But they're early examples. That's not an exclusivity element, right? It is to be wider and more inclusive than simply the large, well-structured research infrastructures. We're already working with elements such as citizen science groups and so on to see how they can also profit from that. We have, as I mentioned earlier, there's working jointly with a number of these competence centers and centers of expertise who are dealing with specific use cases from other research infrastructures, other communities that are outside S3. And those are giving good examples and best practices which can be reused further down the road.
Very good. Dirk, 1 minute.
Yeah, I mean, okay, I will try to make it very short, but I would say there is a responsibility by essentially whoever is involved in say, providing infrastructure services of making use of this opportunity for looking for synergy effects. And I find it, say, extremely beneficial, I mean, to work with communities to see of what can we do to support the integration of different tools. And from the perspective of e-infrastructure service providers, we really have to make sure that we facilitate this kind of integration.
Very good. I think we are closing to the end, very close to the end. We have one minute and a half left. I think it's a very rich area that we are only starting, and we're at the very beginning, actually, not of the, I would say, of the philosophy that is behind, because this is not a new philosophy, as all of you have highlighted, but of the fact that we are building it now as an open, I would say, infrastructure community, as an open data spaces for all. So these are totally new challenges that we will be all facing. It goes without saying that this infrastructure has to be designed in co-design and in co-creation with the different communities that are there. And when I say communities, I'm not only referring to the research communities, but also I'm referring to the private communities, our SMEs and our big industry, because at the end of the day, we have to create also wealth and economic value out of those. I think these are the huge challenges that we have in terms of creating the data, creating the interoperability of data, as you have highlighted, creating the infrastructures that would be bringing all those data together and all those communities together for more and more shared and joint work and cooperation, and ultimately providing the services, be it computing services, AI services, and all this on top of that to make the whole thing valuable in close cooperation between the suppliers. And this, in this case, it's the technology suppliers that could be European industry, but also academia that we have working in different areas, but of course also the users. So I think these are the main elements that I would like to consider from this discussion. And I would like to warmly thank our three panelists here. So starting from Franois and continuing to Dirk and Bob. I hope you enjoyed this first discussion, which was really an introduction to the matter. And I'm pretty sure that in next events and over the years, as we work further with the partnerships here, we will have the chance to further elaborate on all those super interesting topics. Thank you all, and thank you very much the audience who was with us this afternoon. Thank you.
Thank you. Thank you.